how we can calculate the earth pressures. Now currently we have, the most used two methods are Rankine and columns. First we can discuss about Rankine. Rankine, the lateral earth pressure coefficients will be equals K active will be equals 1 minus sin phi divided by 1 plus sin phi, and the K naught will be equals 1 minus sin phi. And the earth pressure, total earth pressure will be K active into the vertical pressure gamma into H minus 2 into under root K active into C if we have cohesion of or cohesive soils. And K passive would be equals 1 plus sin phi divided by 1 minus sin phi and plus 2 K passive under root into C if we have cohesive soil. So moving on. Yeah, in column theory it's different a little bit because it's considering the friction between the soil and the shoring walls. So the K active calculation and the K passive calculation will be different than the column. It will be different than the Rankine formula. Here's the calculation of the K passive also as well. Here, if we can see, we have the phi is the angle of internal friction for the soil, and we have theta. Theta is the friction between the soil and the wall itself. Yeah, second pressures acting on the wall or loads acting on the walls, we have the water pressures. So we have two types. We have, if we have drained layers, the water pressures here, UF will be equal to this formula. Actually, it's not pure gamma into H. We have like some balance due to the seepage. So the pressure will be reduced a little bit. It will not be gamma into H. It will be reduced due to the seepage analysis, and the value of this pressure will be equal to this formula. Second case, if we have undrained layers. If we have undrained layers, the permeability here will be very low or not permeable at all. So there is no seepage will occur here, and the pressure will be full, gamma into H. And there is no reduction will be applied for the water pressures on the retained side. Yeah, so regarding the geotechnical design, what we need to do the geotechnical design for shoring walls, simply we need the soil strength parameters or shear strength parameters, which is phi, angle of internal friction, and the cohesion of the soil. If we have clay or silt, or sometimes they are using the equivalent Moore column model for rocks, and they are giving phi and C for some types of rock. So moving to the structural design. Structural design, we have the same like any structural element. We have the equilibrium calculation. We can calculate the overall stability of our shoring system. And we have the structure design, section size, reinforcement, and we can use some partial factors based on the codes in a specific area like Euro codes and British codes. So here we are talking about the limit state, structure design limit state. We have the ultimate limit state and serviceability limit state. In ultimate limit state, we are going to design our wall to resist the straining actions like the bending moments, shear forces. Also in this type, we can design the tieback anchors, steel struts, and its connections, anchor bolts, and everything. Also, we can check the overall stability for our shoring system, the overturning of our shoring system. And secondly, we can check we can apply the serviceability limit states, which is the movement of our walls. If it's temporary structure, and if it's permanent structure, we can apply another applications like the crack widths. We can check the crack widths, and this will be depending on the specification for the project. Here we can see the failure modes of our shoring system. So here we have the overall stability failure. So this is why we have to check, or it's a must to check the overall stability. And here we have anchor failure. Here we have also rotational failure. Here we have strut. If strut, something will happen in struts. Here we have the vertical equilibrium failure. So we have to study very well what is the failure modes of our walls and check it, and check the overall stability of our walls. Moving on. Yeah, as we said a while ago, ultimate limit state will be used to design the overall stability of our shoring system. and also will be used to determine the size of shoring walls we need, either diaphragm wall or secant piles or sheet pile section. And for tieback anchors design, the anchor length and spacing between the tieback anchors and number of strands inside each anchor. Also, we can design the strutting pipes if we have pipes, and it will be designed like steel structures, and the connection between the pipes and beams and the splices for steel structure. And in serviceability limit state, we have the displacement limit for our shoring walls. We have to make sure that we are within the allowable limits of lateral displacement, which is commonly used 50 millimeter. Also, it will be varying based on the project specifications, but in most of the places, 50 millimeter will be acceptable. Also, if we have marine applications or we have permanent walls, we can check the crack width and long-term deformation checking, and also we can study the creep and shrinkage. Yeah, so jumping to the design softwares, there is the most important part in our presentation today. We have three types of softwares we are using in shoring design. Which one? The first one is the limit equilibrium, which is actually like the manual calculation. Some we have sample for this, which is reward software or some spreadsheets developed by some engineers. But in limit equilibrium, we are using the column method or Rankine method, and we are calculating the straining actions and overall stability like the manual calculation exactly. And we have the second type of softwares called beam on elastic foundation method or modulus of subgrade method. In this softwares, it's more advanced and it's modeling the soil as a springs with a stiffness, which is the modulus of subgrade or horizontal modulus of subgrade for soil. And this softwares like Wallop or Freo from Oasis Group. And finally, and which I am recommending also, the finite element method. Finite element method, we can use Plaxis or Abacus or FLAC, any available software commercially for your company. But the finite element method, it has a lot of features, like you can model the complicated shoring designs if we have two-step walls and we have existing buildings. So in finite element method, we can check everything. We can check the displacement outside the shoring wall. We can do seepage analysis. So it's very important software, and it will be useful and easy for the engineers to use. Here we have the fourth section. We have the case study. Actually, this project was in Abu Dhabi. It's now constructed. I think it's finished. And in this project, we have 5 basements below the ground. Excavation was around 23 meters. And we have existing building. If you can see at the side, at the north side, we have at the east side existing road with surface road. And we have at the south side, we have the existing parking, car park. And another for the west side, we have existing road and existing building at all. The shoring system was diaphragm wall, and the excavation, as we said, 23.5 meters. The embedment depth for shoring wall was 8 meters, so we have 8 plus 26, so it was 34.5 meters depth. We have used 2 levels of steel struts, if you can see the shoring layout here. And water table was around 1 meter or 1 to 2 meters under the ground level. So it was very risky project. We have very high water tables there, and anything will happen, any seepage in the from wall would be risky. And also the watering people did good design for this project. And here some photos from actually this project constructed by Amico Foundations. And here we can see some, here's the construction sequence as we explained before. There's the drilling rig or the diaphragm wall cutter. And here if you can see the guide walls, there's the installation of shoring wall here. And after excavation or during the excavation, we can see some photos here. There's actually the ramp to down, so the trucks can go down and remove the excavation disposal. So state of art. Now we can summarize what we have said today. Yeah. So in order to do design and study any shoring design or watertight system shoring design, we have first to evaluate the site constraints. If we have existing building, existing tunnel, existing roads around us, so we have to evaluate what is the required quality of this wall and what is the performance criteria. Second step is evaluation of the geotechnical profile, and this is very important point. So if we have very weak soil layers, we have to get the geotechnical parameters for those layers, and we have to have like good judgment for the geotechnical design parameters. Third step is a study of performance of the shoring wall. What is the allowable limit for displacement? What is the type of shoring wall? We can use diaphragm wall or secant piles. Also, we have to study the cost of the walls. We have to choose the best quality and also the cheapest solution. We have to study the constructability on site. Step number 4, how we can construct this wall. In some cases, we cannot construct the diaphragm wall because the size is very small. We have tanks, we have big machines, and we have to study the access for our site and many things we have to study regarding the constructability on site. And step number 5, we can carry out our geotechnical design. And the last step will be adopting the quality standards and safety for our project. Yeah, so evaluation in the field. Currently, Blacksys has launched, or some years ago, the Blacksys 3D. So this Blacksys 3D software, it's amazing. We can use for any complicated project. As you see here, we have circular shaft or existing circular shaft, and we have some excavation around the shaft. So we can model all of this actually. And if we have high water level, we can do the seepage analysis. We can check exactly what is the displacement outside our shoring system. Here also we have another case. We have some excavation, deep excavation beside existing tower resting on pile foundation. So the 3D modeling and finite element method modeling in shoring design will be very useful for any project, and in the coming years will be used. Yeah, and career paths and job opportunities. For geotechnical engineers, I think you can start training, and I think the geotechnical engineers is having good time these days because a lot of problems are happening due to the geotechnical design, poor geotechnical design. So most of the engineers now and the clients are searching for good quality engineers, and you can train yourself and start in using new softwares, reading about the formulas which the softwares are using. Also, you can study the construction methods because in geotechnical engineering, it's not only design. We have to check the constructability on site, how we can construct our design. So this is very good point for the fresh graduate engineers, and they can implement in their career path.